Hello, Hunter, and hello, Brandon. We are talking about projectiles today. It's a classic physics problem. So first we're going to start with, you can show them your picture. There, I'll get that to you through the system. And I will describe what a projectile is. So a projectile, we're going to look at it as a launched object. And there's only one force. Once it's launched, there is some force that's launching it. There's gunpowder in this cannon, and there's an ignition process, so there's an explosion inside the cannon. We're not interested in that. What we're interested in is once it leaves the cannon. So once the projectile is launched, the only force acting on it is what?
Air resistance, I guess, and gravity.
You got it. The only force acting on it is gravity. There is a minimal amount of air resistance, but we're going to ignore that. So the launch projectile, the only force acting on it is gravity. Once it leaves its launcher, that is. So we're going to be looking at projectiles that are fired at an angle. So let me get a sketch of what you have. So I have the cannonball coming out, and it's going like this. What's this path called in mathematics? What path does a projectile follow?
A curve.
It's a curve, but it has a special name, parabola. That's right. So, all right, let's make a note of that. Once it's launched, if the only force acting on it is gravity, it will follow a parabolic path. It follows a parabolic path. And I'm going to add here, we are ignoring air resistance compared to the air molecules. The cannonball, it's not hardly affected at all. I'm only interested in this problem from where it is launched, the height of where it's launched, to where it's coming back to the same height. So actually, because the nose of the cannon is above the ground, we know it's going to go past that, but our problem is only going to cover this amount right now. So we'll say somehow this cannon is buried in the ground and it's launching right at ground level. It's a new technique, the hidden cannon. So anyway, there are a couple vectors you have drawn for you. Here's what I want you to do. Here's the first vector, and I want you to call that V. How about that? V for vector. So you're going to have to write small. And as you can see, I wrote in some components. So here is the horizontal, and here is the vertical. I'll color code mine. You can't do that, but let's say I'll do green and blue. They'll show up. So for mine that's green, I want you to call that V sub x. Can you write small and write that in, V sub x? Does that show up on the video, that little V sub x?
Let's see.
And the blue is the V sub y. So I want you to go across to all of the vectors that are like that and put in V sub x on the horizontal part. It's going to take me a little longer than you because yours are drawn in there. V sub x on all the horizontal parts, V sub y on all of the vertical parts. What happens at the tippy top here? What happens to the V sub y? It's gone. So on the top, it's shrunk away. So all I have is the actual vector itself is the same length as the horizontal part. And then it starts coming down. And I'm sorry, I should have had this up. Slows us down, but right with you. So that's V sub y and V sub x. And I've got got one more to do. V sub y and v sub x. Alright, mine looks a little lopsided. This should be at the exact same height as this one. Alright, so what we're doing with, let me see that you have them all labeled. Vy's, Vx's, and V's. I'll put V on mine as well. Alright. Did you get all your Vy's and Vx's in? Do they fit? I know it takes, it's,
I'm just copying this time.
okay. Alright. It's hard to see, I should have made that a little larger, but I can see you made a good effort here. Alright, now we are going to get into the meat of the issue. Let's take a note. I'm going to write it in blue because I indicated it on blue up here. The y components. Let's just pretend the only thing you can see is the blue. You can't see the yellow vector, you can't see the green horizontal, just the blue. So if you're just looking at these blue guys, can you tell me, it's probably even more clear on your paper, can you tell me what is happening to the blue vector on the first half of its journey? So is it growing, shrinking, growing or shrinking? What do you think, Brian, the blue vector?
Should I say shrinking?
Right, so the y component shrinks to 0 at maximum height. So at the maximum height, it shrinks away to 0. And notice at that point, is it facing upward or downward on the first half, Emily? Number 1?
Upward.
Right, so it shrinks to 0, so it's a positive value on the way up. Shrinks to 0, positive direction. Hey! Welcome. Here's what we're working with today. So the y component shrinks to 0 at the maximum height, and it's in the positive direction until it disappears. All right, what about on the second half? So what happens after this blue line, the second half? Can you describe what happens to the vertical component, Emily Davis? Oh, Emily number 2.
It gets bigger as
Right.
it goes down.
Right, because it shrunk away to nothing.